Your review for your systems of equations test. Remember, it will be non-calculator. First question, using substitution or elimination to solve the following system of equations, you must use each method once. For example, you could solve part A by elimination and part B by substitution. I'm going to choose to solve part A using substitution because I believe I can easily. Actually, I'm going to solve part A using elimination. They're both pretty simple. I'm just going to choose elimination right here because whenever I add these, my 3y right here is positive, my 3y right here is negative. The 3y's will cancel out. And x minus 3x is a negative 2x. 1 plus a negative 15 is a negative 14. Divide by negative 2. X is equal to positive 7. Then I can plug 7 into either equation and solve for y. So 7 plus 3y is equal to 1. Subtract 7 from both sides. 3y is equal to negative 6. Divide by 3, and y is equal to negative 2. So my solution here is the point 7, negative 2. That is the point where these two lines would intersect. B, I'm going to solve using substitution. So I'm going to solve the bottom equation for x by adding 2y to both sides. So that gives me x is equal to 2y plus 11. Then I'm going to substitute this value into x in my first equation. So I'd have negative 7, and instead of x, I'm putting what it's equal to, 2y plus 11 minus 2y is equal to negative 13. Then I'm going to distribute my negative 7, so I get negative 14y minus 77 minus 2y is equal to negative 13. I'm going to combine my like terms, so I have negative 16y on the left side of my equation minus 77 is equal to negative 13. Now I'm going to add 77. So I get negative 16y is equal to a positive 64. Divide by negative 16, y is equal to negative 4. I'm going to plug this y net is equal to negative 4 into this equation to solve for x. So 2 times negative 4 plus 11, 2 times negative 4 is a negative 8, plus 11 is a positive 3. So the solution for this system is the point 3, negative 4. That is where these two lines will intersect. Number 2, graph the following systems of inequalities on the graph below. So my top equation is already solved for y. My bottom equation, I need to solve this for y, so I'm going to subtract x from both sides. So that gives me 2y is less than or equal to negative x plus 10. Then I'm going to divide by 2. So that gives me y is less than or equal to negative 1/2 x plus 5. So at positive 5, and I know my graph is going down 1 and right 2. My other equation, y is equal to negative 2, or sorry, is equal to greater than or equal to 2x minus 5, is going to start down here at negative 5. It's going to go up 2 and over 1. And these both have equal to in their inequality, so that's why I'm drawing the solid lines. If they'd just been greater thans and less thans, I would have had dashed lines, but because they have the equal to underneath, I'm going to have solid lines. I do need shading. Okay, my first inequality, it was less than, so it would have been shaded below. I'm going to lightly shade right there. My first one right up here was y is greater than or equal to 2x minus 5, so that's greater than is above it, so that's all this right here. And then I'm going to darkly shade where these two overlap, which is this right in here. Number 3. Each year, an architecture firm employs senior interns and junior interns. Senior interns interns receive $400 per week, and junior interns receive $300 per week. This year, a minimum of 7 but no more than 13 interns will be hired. The amount spent per week on interns cannot exceed 4,000. Write a system of inequalities that would be used to find the possible number of interns. Alright, so I'm going to let J equal my junior interns. And S equal my senior interns. So I know that my junior interns plus my senior interns has to be greater than or equal to 7, and junior interns plus senior interns has to be less than or equal to 13. I also know that senior interns receive $400 and junior interns receive $300, and they cannot exceed $4,000. So I'm going to multiply the pay that they would receive by the number of interns. So 300J plus 400S has got to be less than or equal to 4,000. So this is one way of expressing it. Some people, instead of writing this as 2 inequalities, would have written this as 1, where they had an inequality sandwich. So 7 is less than or equal to J plus S, which is less than or equal to 13. That is correct also. Number 4. A rectangular patio shown in the diagram below is enclosed on 3 sides by a fence. The area of the patio is no more than 300 square feet. The total length of the 3 sides of this fence is no more than 60 feet. Which system of inequalities can be used to find the values of L, the patio's length, and W, the patio's width? Okay, so I know whenever I'm enclosing this, I have 1 length, but I have 2 widths. So my length plus 2 widths has to be less than or equal to 60 feet. That's just the fencing that's going around it. Now I know the area is no more than 300, and the way I find the area of a rectangle is length times width. So length times width has to be less than or equal to 300. Number 5. 2x plus 4y is equal to 16. Into y is equal to mx plus b form, and 6x minus 5y is equal to 20 into y is equal to mx plus b form. Right here I'm going to solve for y, so I'm going to subtract 2x from both sides. So that gives me 4y is equal to negative 2x plus 16 divided by 4. So y is equal to negative 1 half x plus, and 16 divided by 4 is 4. My other inequality, I'm going to subtract 6x from both sides, so I get negative 5y is equal to negative 6x plus 20. Divide by negative 5. And that gives me y is equal to 6 over 5x minus 4. So my first line has a y-intercept at 4 and a slope of negative 1 half. So it's going to go down 1 and right 2, down 1 and right 2. There is no shading on these because they're just equations, they're not inequalities. My second line has a y-intercept at negative 4 and a slope of 6 over 5. These don't intersect exactly on your test. They will. Right here I'm just going to put in an approximation of where these are. You could use substitution to find this exactly. You don't have to do this on your test. They will intersect at an exact point. 1, 2, 3, 4, 5. So about 4.8, about 1.7 is what I would say they intersect at. This is again approximate. On your test they will intersect at an exact location. Flip over. Number 6. The sum of two numbers is 575. Twice the larger number is 1150 minus twice the smaller number. What are the two numbers? Alright, so you know that there's some, so I'm going to have a smaller number, S, and a larger number, L. So S is my smaller, and L is my larger. And I know that S plus L is equal to 575. Twice the larger number, so 2L, is, that means I put an equal sign, 1150 minus twice the smaller number. What are my numbers? Okay, so I need to solve the system of equations. I'm going to, these look kind of similar, so I'm going to put them both into, or I'm going to solve this one for L. I'm going to divide by 2, and I get L is equal to 575 minus S. And if I substitute that in right here, I end up with S plus 575 minus S is equal to 575. When I combine my like terms, I have an S and a minus F on the same side, so I end up with 575 is equal to 575. We know whenever our sides equal each other that means that there's an infinite number of solutions. So any two numbers that add up to be 575 will work in both of these equations. So you could choose 0 and 575. You could choose 5 and 570. You could choose 575. Any two numbers that add up to be 575 will work in both of these equations because whenever I use substitution to solve this, I end up with this true statement of 575 is equal to 575. Number 7. A craftsman wants to spend less than $300 on supplies for making bracelets and necklaces. Supplies for one bracelet cost $4 and supplies for one necklace cost $9. This relation is shown in the graph below. So they have graphed this for you. What they want to know is the craftsman wants to make at least 5 more bracelets and necklaces. What is a reasonable solution? So anywhere in this region where you have 5 more bracelets than necklaces would be a reasonable solution. So your bracelets has to be equal to 5 plus your necklaces. Or, because this is my x-axis and this is my y-axis, if you want something that you can graph, you subtract 5 from both sides. You'd have necklaces is equal to negative 5 plus b. So, you could have, we extend this down 1, negative 5 would be right there, that'd be your y-intercept, and then we would go right through here, here, and anything, you must make, bracelets must be 5 more than the necklaces. Greater than or equal to. So this would be n is less than or equal to whenever I move that over. So it's going to be anywhere down in here. So any point that's in this region would work for this. So you could make 50 bracelets and 0 necklaces. That would be true statement. It's at least 5 more bracelets and necklaces. The hypotenuse of a right triangle is 20 inches long. Leg of a triangle Y is 3 inches less than twice the length of the other leg. Which system of equations can be used to determine the length of the two legs of a right triangle in inches? Well, we know that a right triangle has x and y, then the hypotenuse h, if this is, will fit into x squared plus y squared is equal to my hypotenuse squared. And I know the hypotenuse is 20 inches long, then I know that x squared plus y squared will equal 20 squared, or 400. I know a leg of this triangle y is, so I have y equals, anytime you have is equal, 3 inches less than, so minus 3, twice the length of the other leg x, so 2x. So those would be the two equations I would be working with.